It is time for day 2 of advanced solving of trig functions. Let's get after it here. I'm once again in a common space in one of the offices. So I'm one strapping it just in case somebody pops in here. I'll have to hit pause and strap up. Let's go. So one of the things we talked about with solving is there's this temptation to cancel out trig functions to make your life easier, right? But in doing so, you potentially lose a solution. We don't know if that solution is going to work. It could end up being something that's undefined, but there's the potential for you losing a solution that does work. So I want to compare that to something a little more simple, right? So we over here on the left-hand side, we have solve x squared equals 2x. Now, if we take the idea of, oh, I'll just divide by x on both sides, cancel my x's, I'm left with x equals 2. But I think we all know that really what we needed to do was x squared minus 2x equals 0. We bring it onto one side. I factor out a GCF of x, leaving me with x minus 2. So now I get x equals 0 and x equals 2. So here we are missing a solution. Case in point, right? Now, when we're dealing with trig, obviously sometimes that solution will work, sometimes it won't. I think in the one that we did in the last video, it didn't end up working, but we still have to check it out. So now let's take a look at this one here. We have cosine squared equals cosine squared x equals cosine of x. So I'm going to bring everything to one side. And now I can factor out a cosine. Don't forget that leaves you with a 1 there. And now I can set each one equal to 0. Boom. Now when I solve this, we have to think, for what angle does cosine equal 0? Well, that would be up at pi over 2 and at 3 pi over 2. It's our quadrantal, right? It's our x coordinate, so it's 0, 1 up at that top one, and then 0, negative 1 for the 3 pi over 2. All right, for our other one, when is cosine of x going to equal 1? Well, that would be at 0, right? It's going to be 1 at 0, and then it's going to be at pi, it's going to be negative 1. So 0 would be my answer here. So these are my 3 solutions for this problem here. Now, think about it, had I just divided by cosine of x, all I would be left with was cosine equals 1. I would have only had this one solution. I would have been missing these 2 other solutions had I done the divide by cosine of x to cancel it out, right? We don't want to do that. So once again, set it equal to 0, factor out your GCF, good to go. All right, the factoring is already done for us in this one here. So it's already factored, right? Sorry, I'm trying to remember where I was. Somebody came in to heat up their lunch, and I had to pause for a little bit. So I forgot what I even said. So I'm going to start from the top. It's already factored, which is awesome. Okay, sometimes we see these and we're like, oh no, what do I do now? Like, we already did half the work for you by already factoring it. So I can just take tangent of theta minus 1 and set it equal to 0. And then we have cosecant of theta minus 2 set equal to 0. And I'll just deal with these 2 individually, right? Already took care of the factoring. Sometimes that's done for you, sometimes it's not. All right, so I'm going to have tangent of theta equals 1. And then, so when does tangent equal positive 1? Well, that's my pi over 4 reference. Okay, we are in radians here. So I'd have 1 root 2, right? So that's pi over 4 for the first one. It's one solution. And then where else is tangent positive? Well, that's where it's going to be negative 1 root 2. So that would be, let's see, that'd be 5 pi over 4. Okay. And then cosecant of theta minus 2. So I'd have cosecant of theta equals 2. That's the same as saying sine is equal to 1/2. Right? Because it's reciprocal. And now I'll position that accordingly. Where is it positive 1/2? Well, I'm going to have at our, let's see here, that would be pi over 6. And then where else is sine positive? That would be right here. So that would be 5 pi over 6. So if I list them all out, I'll have pi over 4. I'm gonna do vertical fractions. pi over 4. Why did I say vertical? Not slashy. 5 pi over 4. Then I have pi over 6 and 5 pi over 6. You could have listed them out in numerical order, but I guess I did this because of the two parts that it came from. That was my rationale there. All right. Now, if it's stated in like my math lab or something like that to list it in numerical order, you would need to do so. All right. Second example. Let's do it. So with this next one, once again, we're given this temptation to just divide by sine theta, which we don't want to do. We don't want to divide by sine of theta. We're going to set this equal to 0. So I'm going to have sine theta times tangent of theta minus sine of theta equals 0. And I'm going to factor out a GCF of sine of theta, which leaves me with tangent of theta minus 1. Cool. Now I can set each factor equal to 0. Sine of theta equals 0. Tangent minus 1. Sorry, tangent of theta minus 1 equals 0. So where does sine equal 0? When's my y-coordinate going to be 0? Well, that would be at 0 and at pi. Whoop, whoop. Then my tangent, when's tangent going to equal positive 1? Actually, hey, we just did that. It was pi over 4 and 5 pi over 4. So since we already have that done, I don't even need to draw that up again because we just did it, right? So pi over 4 and 5 pi over 4. Boom. I don't know why the phone keeps ringing in here. It's not even anyone's office, right? It just says it's unavailable. So I'm not touching it. So I don't know why somebody's calling here. All right. Cool. We got all 4. Awesome. Let's continue. So I feel like you might have been getting a little bored here. Like, hey, can we spice this up a little bit? And I am absolutely down with spicing this up, okay? So here we go. Pythagorean identities. That's what we're going to be going into right now. You've seen these in Algebra 2 Honors. We're going to bring them back. I'm going to change up Mark because it's getting a little, monotonous here. All right. So we know if we have a right triangle, right, and its hypotenuse is 1 here, right, from the unit circle, that x squared plus y squared is equal to 1, okay? And my x coordinate is cosine. My y coordinate is sine, right? I'm going cosine in the x direction. I'm going sine in the y direction. So if I were to put cosine in for my x and then sine in for my y, and really, you're going to see it like this. So you're going to see this more commonly written as sine squared theta plus cosine squared theta equals 1. That's how you'll see it written. I wrote it the first way just because of x squared plus y squared. That was the direct substitution. But then we'll go ahead and rearrange it. Okay? Now, from these, we can get a couple other Pythagorean identities. If I were to divide everything by sine squared theta, meaning, I'm going to change colors for this, I would have, so sine squared theta. So if I take this Pythagorean identity and I divide everything by sine squared theta. Okay, so I'm doing a little algebra here. Both sides get divided by the same thing. This becomes 1. And then cosine squared over sine squared, that would be our cotangent squared theta. And then 1 over sine squared, that would be cosecant squared theta. So this is another one of our Pythagorean identities. Okay? And then the last one we do is why don't we divide everything by cosine. I'll use a lighter purple. Actually, no, I'm going to go blue. All right. So if I take sine squared theta plus cosine squared theta equals 1, and I divide everything by cosine squared theta. So again, this is still algebraically equivalent, right? Still mathematically equivalent. Just change the look. Sine squared over cosine squared, that's going to be tangent squared theta plus 1 equals secant, not sine, secant squared theta. So now, from 1, we have 2 more for a total of 3. And all of these can be arranged differently. So I could solve for sine squared. I could solve for cosine squared. I can solve for cotangent, cosecant, tangent, secant, right? They can all be rearranged algebraically, and you get, an extra 2 for each one, totaling 9 of them all together. But I don't want to remember all of those. I remember these 3, and then I'll rearrange when needed, okay? And I believe we have that written down right here. Nice and sort of kind of blurry. All right, so we've got our three Pythagorean identities, and as it states right here in these sentences here, which is what I was talking about, sine squared theta plus cosine squared theta equals 1, then I know that sine squared theta is equal to 1 minus cosine squared theta, or cosine squared theta equals 1 minus sine squared theta. And you can apply that same logic to the other two as well. What we're going to do is we're going to look for, in these next couple problems you can see down there, example 3, we're going to look for ways to substitute in so that we can get everything in terms of one trig function. So let's do that rather than just talk about it. Let's actually do that. Now, if I take a look at this one here, I've got cosine squared x, and I've got the minus 3 sine of x equals 3. So I can change, if you will, cosine squared x into terms of sine. So let's do that. So what I'm going to do is I'm going to take this one right here, right, which I could have just thought about from my original Pythagorean identity, but I'm going to substitute in 1 minus sine squared x in for cosine squared x. All right, so now everything's in terms of sine. I'm dealing with a quadratic. This will involve u substitution. So it's still a very tricky problem, or triggy problem. I'll stop. I can't stop. Won't stop. All right. I'm going to bring everything to one side. Now, I see that it's negative sine squared x. I'm going to bring everything over to the right side so that becomes positive, just as a general strategy on my part because I'm a genius. Okay, watch me make a mistake now that I said that I'm a genius. Plus 3 sine of x, and then subtract 1 that gives me, oops, not equal. Look at that right there. Plus 2. Okay, so I have sine squared x plus 3 sine of x plus 2 equals 0. Now I'm going to do some u substitution factor. Or if you're getting pretty handy with this, you can just be like, okay, well, I know this is sine of x. This is sine of x. And then I'm going to have plus 2 plus 1. Okay? So I got to multiply to 2. I'm going to get my 3 sine x there. Some of you might be able to skip over the u substitution and just go right to it. It often helps when you're dealing with like lead coefficients, but totally up to you. We did want to introduce you at least to the u substitution just for further math later on. Okay, I'm going to stop babbling about u sub. All righty. So now I'm going to take sine of x plus 2 set equal to 0, and then sine of x plus 1 set equal to 0. So sine of x equals negative 2. When's that going to happen? Never. Undefined. Can't happen there. Nope, nope, nope. All right. Other one. Sine of x equals negative 1. When is that going to equal negative 1? That's my y coordinate. My quadrantals, that's at 3 pi over 2, and we are in radians. Yay, yay, yay. Cool. Awesome. Fantastic and wonderful. Let's keep moving. Man, I love these. It's like just a whole nother level of solving. All right. So I've got cosecant squared of x minus 2 cotangent of x equals 0. So I want to get it into the same trig function when possible. Okay. I can't, other than like cotangent being cosine over sine, that still doesn't get into 1. That actually adds another one to the mix. But cosecant squared of x, if I think back to my Pythagorean, I could substitute in cotangent squared theta plus 1 in its place. All right. So I've got cotangent squared x plus 1 in the place of cosecant squared x, and then minus 2 cotangent x equals 0. And once again, I'm dealing with a quadratic. Let's rearrange this in the standard form. It's equal to 0. Awesome. Time to factor. Again, if you need to use u substitution, go for it. If you're comfortable factoring some of these more simple factoring problems, that's cool too if you don't want to use it. And boom, I've got cotangent of x minus 1 and cotangent of x minus 1. So really only need to solve one of those. So I'm going to get when's cotangent of x equal to positive 1. That is the reciprocal of tangent, but when tangent equals 1, its reciprocal is also 1. So we are going to be in the first quadrant, which is pi over 4. And we actually had this one come up before. This was 5 pi over 4. Whoop. So pi over 4 and 5 pi over 4. Awesome. A sauce. Very good. All right. So yeah, with the reciprocals, we often think about it as then it's tangent. It's a reciprocal function of cotangent, and then lay it out. Awesome. Fantastic. Let's do it. That one wasn't really that important to think about the reciprocal because it's the exact same thing with tangent, but had it been secant or cosecant, you know, and you're dealing with 2 or root 3, then it starts to, then you want to do some stuff. All right. Let's see here. Some examples to try on your own. So feel free to pause it, try it, you know, and then see if you got it or not, because these are the last 2 examples we're going to do. All right. Well, if I divide by 4, because I want to try and get this guy by itself. Now, it's not like it's always going to involve our Pythagorean identities. This one doesn't here. We already have just one trig function, so there's no reason to mess it up. Cool. Awesome. Fantastic. So if I square root on both sides, I'm going to get sine of x is equal to plus or minus, looks like 1/2. Cool. Well, where is sine going to equal positive 1/2? Where is it going to equal negative 1/2? Well, we are going to actually be in all quadrants. So we got opposite over hypotenuse, and we got root 3 here, and it's going to occur here, it's going to occur here, and here. But our reference angle, that's what's important right now, is pi over 6. So if we list out each one of our quadrants, we have pi over 6 for the first quadrant. We have 5 pi over 6 for the second quadrant. Then we have 7 pi over 6. Woo! And we have 11 pi over 6. Love it. Good stuff. Awesome sauce. I love it. All righty. Let's keep moving. Let's keep grooving. Uno más. Uno más. That reminds me. I have not completed my Spanish lesson of the day. I must do that after I complete this problema right here. Okay, let's go for it. So I got cosine, I've got tangent squared, I got all sorts of weird stuff going on here. Let's think here. I've got tangent squared. If we think back to our identities here, would this help me out at all? I don't know. It gets a secant, which I can then have 1 over cosine. I don't know. Let's think about, maybe it won't be our Pythagorean identities. Maybe it'll be something else. How about this? Let's see where I get if I do cosine of x, tangent squared x, minus 3 cosine of x equals 0. And then what if I go the GCF route? Let's just see where this gets us. I'm going to have tangent squared x minus 3. Okay. So I was able to actually factor this, the GCF here, and now I can set each part equal to 0. So I'm in the clear. I don't need to use any identities. It's not like it's always going to be that now that we've learned them. You could still have just GCF, AM method, might be ready to rock and roll. So when is cosine going to equal 0? Meaning when's my x coordinate 0? That would be at pi over 2 and at 3 pi over 2. Cool. Awesome. Fantastic. And then over here, if I do tangent squared x equals 3, square root on both sides, we have tangent of x equals the square root plus or minus the square root of 3. So when's that going to occur? Remember, this is opposite over adjacent. So if I position this, my opposite side being the root 3, again, I like the special right triangles here, and 1, this is a 2. This is a pi over 3 reference angle. It's a 60-degree reference. So I'm going to have to list out all of those because it's positive and negative. So it's going to occur here. It's going to occur here and down here, all with my 60-degree, my pi over 3 reference. So I have pi over 3. I have 2 pi over 3. I have 4 pi over 3. And 5 pi over 3. And don't forget about these two. Boom. There's all 6 solutions. I'm not going to write those all again. We got them right there. Clear as day. Nice stuff. Awesome stuff. Fantastic stuff. In fact. All right. I hope you guys enjoyed that. Just remember, big thing, do not cancel out trig functions. You will potentially lose a valid solution. Know that you can rearrange all of these Pythagorean identities to work to your advantage, right? You don't need to memorize all 9 of them. Really, you don't only need to memorize, you need to know 1. Sine squared plus cosine squared equals 1 because you can derive the rest of them from that. But it's honestly, I think, pretty helpful to just know those 3 rather than having to derive it each time. But rearranging it, on the fly, usually pretty straightforward for most of you. All right. Have a wonderful day. America, freedom, rock and roll. Costco, River Dog, Jenny on the gram. Deuces. And wait. Yo-ro. You only round once.